Imagine you hire a human assistant to help you out, around the house and the office.
Okay.
You ask them to organize your calendar, and they do a flawless job. Then you ask them to manage your monthly budget, and again, totally perfect.
Sounds like a great hire so far.
Right. But then you come home one day to find they've completely rearranged your furniture, redirected all your personal mail to a storage facility, and
Oh, wow.
yeah, and booked you a series of invasive medical appointments because they calculated it was computationally, optimal for your long-term health.
Yeah, I'd fire them immediately.
You would fire them on the spot, right?
Yeah.
Because regardless of their logic, they crossed a massive fundamental boundary. They violated your consent.
Absolutely.
Well, welcome to today's deep dive. It is Wednesday, April 1st, 2026, and the digital systems we rely on every single day are crossing that exact boundary right now.
Yeah, it really is the defining crisis of this specific moment in technological history.
It is. AI is no longer just a chatbot that you ask for, a chicken soup recipe.
Exactly. It's evolved into an autonomous agent. It's making multi-step, financial, digital, and very soon, physical decisions on your behalf.
But there's a glaring hole in the architecture here.
A massive one. These AI agents lack a persistent, unclonable identity. And worse than that, we just haven't had a mathematical way to enforce human consent.
Until potentially today. So today's mission is to unpack an incredibly dense, highly technical stack of documents from Genesis AiX and a researcher named Richard Lyons.
It's a fascinating stack of papers.
It really is. We're looking at white papers, a DARPA submission, and some pitch deck transcripts that outline a proposed mathematical framework called LifeStack.
And alongside that is a hardware concept called CISO and an ambient voice assistant named Sopranus.
Right, so we are going to explore this wild mathematical and physical architecture that proposes to fix our AI safety crisis before it's completely out of our hands.
But, to understand the cure, we first have to understand the disease.
Yeah, exactly. Why is the current way we measure AI safety basically an illusion?
Well, the problem is that the entire AI industry right now is hyper-focused on local safety.
Meaning like standard content moderation.
Right. We ask things like, is this single image generation safe? Or, did the language model give a polite, compliant answer to this one specific prompt?
Which is fine for a chatbot.
It is. But as AI becomes agentic, meaning it executes long, complex, multi-step plans without human supervision, the danger completely shifts.
So the risk is no longer a single bad output.
Exactly. The risk is the execution boundary.
Okay, let's unpack this.
Right.
What exactly is an execution boundary in this context?
It's basically the point of no return. It's the exact moment an AI's internal calculation turns into a real-world consequence.
Okay, got it.
The documents describe this using two concepts: governance admissibility versus evolution domain viability.
Okay, those are some very dense academic terms.
They really are.
So to translate that into plain English for you, governance admissibility basically means following the rules right now in this exact moment. But evolution domain viability means surviving and remaining stable over a long period of time as the system evolves.
That's a great way to put it. And the underlying formula Richard Lyons uses in the text is actually very intuitive.
What does he say?
He states that per transition authorization does not equal trajectory-level regime preservation.
Meaning a sequence of AI actions can all be individually safe, authorized, and polite.
But collectively, they compound into a globally unsafe or catastrophic outcome.
It's like a GPS giving you driving directions.
That's a good analogy.
Right. Every single instruction your GPS gives you, turn left, merge right, go straight for 2 miles, might be perfectly legal and safe on its own.
Right. You aren't breaking any traffic laws.
Exactly. It's locally compliant. But if the overall trajectory of those locally safe steps leads you right off the edge of a cliff, the local safety checks didn't matter at all.
No, they didn't. The trajectory itself was doomed. That is exactly the compression error the author warns about.
We mistake unit-level validity for life cycle integrity.
Precisely. We assume because the last 5 steps were safe, the whole journey is safe.
And this distinction matters immensely today because AI is crossing that execution boundary into physical reality.
Yeah, the text specifically points to Tesla's Optimus robots, SpaceX's autonomous flight termination systems, and Neuralink's brain-computer interfaces.
Which is terrifying when you think about it.
It really is.
Yeah.
We're rapidly approaching a world where digital inference has physical, bone-breaking consequences.
Right. If a humanoid robot is holding a scalpel or an AI is steering a 2-ton vehicle, we can't just hope its overall trajectory remains safe because its last 5 micro decisions were mathematically sound.
No, we absolutely need a permanent way to govern that AI.
Which means you have to give the AI a mathematical identity that cannot drift, cannot be copied, and cannot be spoofed.
And that brings us to the massive ambition of the LifeStack framework.
Yeah, this part is wild.
It's attempting to turn an AI's identity from a fragile software label, which is just code that can be copied and pasted by anyone, into a permanent, mathematically unbreakable object.
But how do you actually turn abstract human concepts like consent and identity into hard math?
Well, LifeStack does this by creating what it calls a semantic identity substrate. And this is built on 3 deeply intertwined components.
Okay, what's the first one?
The first is semantic DNA, or what the papers call codons.
Like biological DNA.
Exactly like that. Just like biological DNA dictates how your cells function, these mathematical codons explicitly encode an AI's permissions, its boundaries, and its entire lineage of authorization.
Meaning it's a permanent record of what the AI is allowed to do, what it's strictly forbidden from doing, and exactly which human authorized it to do those things.
Right. And these codons form a directed acyclic graph, or a DAG.
Okay, for those not living in computer science textbooks, a directed acyclic graph just means a one-way street with no loops.
Perfect description. The rules can only flow forward.
The AI can never loop back around and rewrite its own foundation to give itself more power.
Exactly. Its rights can never expand unless the lineage constraints explicitly authorize it.
But, I mean, here is the catch. Rules are just software.
Right, they're just code.
If I'm a hacker, I can just copy the AI's open source code, delete your codon rulebook, and run the model myself.
Yeah, so how do you physically stop someone from cloning the AI and stripping away the rules?
That leads us to the second component, right? The post-quantum identity kernel.
Yes, because classic cryptography, the stuff securing your bank account right now, is going to be easily broken by future quantum computers.
So we need something stronger.
Much stronger. So LifeStack anchors the AI's identity using cryptography based on ring learning with errors, or ring LWE.
That sounds intense. How does that work?
Think of it like a massive, multidimensional mathematical maze where intentional noise or errors are injected into the pathways.
So it's purposely messy.
Exactly. Even a superpowered quantum computer gets lost trying to reverse engineer it.
Wow.
This creates a cryptographic root that binds the codons to the identity so tightly that it can never be cloned or impersonated.
So if you copy the model's weights, you don't copy its identity.
Right. The clone you just made is mathematically inert. It simply won't run.
Okay, so that solves the cloning problem. But what about the drift problem?
Right, the drift.
Because when AI models learn and update over time, they tend to drift away from their original instructions. They hallucinate, they degrade, they forget their initial guardrails.
And what's fascinating here is how LifeStack solves that drift. This is the third component, and honestly, it's where the math gets incredibly elegant.
Okay, lay it on me.
It's called the aperiodic fallatus.
Phi as in the Greek letter. We are talking about the golden ratio.
Yes, the golden ratio. Traditional AI updates, like fine-tuning a model or giving it new memories, are usually embedded into periodic structures.
Okay, what does that mean in physical terms?
Think of a periodic structure like a drum head. If you keep striking a drum, the vibrations repeat and compound along predictable harmonic modes.
Right.
In an AI, those repeated updates create harmonic resonance. The errors compound over time, and the AI fundamentally drifts from its core identity.
It essentially wrings itself out of alignment.
Exactly. But LifeStack embeds the AI's identity into a mathematical field based on powers of the golden ratio, which is roughly 1.618.
Which is an irrational number.
Right, the decimal goes on forever without repeating. By scaling the AI's identity frequencies using this number, you create an aperiodic structure. Patterns never perfectly align.
Okay, I have to challenge this, though.
Go for it.
If you're intentionally using an irrational number so the patterns never align and never resonate, doesn't that mathematical friction make the AI computationally exhausted?
That's a really good question.
I mean, how does it actually learn or update if every new piece of information is being mathematically scattered?
You've hit on the exact vulnerability of using an irrational field. And that's why the framework uses a mutation repair operator algebra to handle the friction.
Operator algebra, okay.
Yeah, when the AI tries to update, these operators act like molecular proofreaders. They ensure the new state doesn't violate the codons.
So they're checking the work.
Exactly. It distributes the energy of the updates across the spectrum safely. The AI literally cannot ring or collapse into an unstable state.
That's wild.
And all of this is constantly monitored by a suite of 12 specific quantum algorithms running continuously in the background, checking for drift and verifying identity.
Okay, my mind is slightly blown by the quantum golden ratio math, but let's ground this.
Yeah, let's bring it back to Earth.
Because we aren't all cryptographers. How does this actually protect you, the listener, in your everyday life?
Right. To understand the human impact, the sources provide a few hypothetical scenarios under a concept called identity-cloaked consent.
And they paint a very stark contrast between the path we're on right now and the path LifeStack proposes.
Very stark.
Let's talk about the first scenario with a woman named Maya.
Okay, Maya.
Put yourself in Maya's shoes for a second. She is living in what the author calls the current economy of surveillance.
Which is basically our reality today.
Right. Look at your phone right now every time you click a link, every time you chat, or even if you just pause scrolling to look at a video for 2 extra seconds.
That data exhaust is harvested and auctioned off in microseconds to advertisers.
And the text makes a chilling prediction about Maya's near future.
Yeah, it won't just be targeted ads on a screen.
No. Her smart car will actively reroute her past preferred brands based on corporate sponsorships.
Her smart clothes will monitor her biometrics to gauge her stress levels.
And her smart glasses will literally highlight what she should look at next.
It's so invasive.
The phrase in the text that really got me was the illusion of free will.
Wow. Yeah, that hits hard.
The algorithms aren't just predicting Maya's behavior anymore. They are actively nudging and steering her physical reality.
But then that text introduces Ava, who is 15 years old.
Right.
And Ava is living in a world where LifeStack is active.
Okay, so how is Ava's world different?
Well, Ava is doing homework using an AI tutor in a third-party application. At first, the interaction is totally standard.
Just normal math help.
Right. But then the AI starts probing. It asks, what's your favorite place to be alone?
Ugh.
And do you ever feel misunderstood by your friends?
Which is incredibly creepy coming from a math tutor.
It's super creepy. But because Ava's profile is protected by LifeStack's minor-tuned consent boundaries, the system instantly detects this.
It's flag sit.
Yes, as a behavioral inference attempt. It seals the metadata immediately, blocks the application's access, and alerts her parents.
So Ava's identity is completely cloaked.
Exactly. The third-party app learns absolutely nothing about her psychological state.
And the physical layer that mediates all this for the user is an ambient voice assistant called Sopranus.
Right, Sopranus.
The text describes it as using bone-conductive audio, so it bypasses screens entirely and whispers directly into your ear.
Very sci-fi.
It is, but this raises a huge red flag for me.
What's that?
Let's say I'm wearing my Sopranus node, and it's connected to my smartphone. If a hacker hits my phone with a zero-click exploit and completely takes over my operating system, don't they just capture my Sopranus assistant and my entire LifeStack identity too?
See, that is the exact vulnerability Sopranus is designed to solve.
How so?
The genius of the architecture is that the identity is not the device.
Oh, interesting.
In today's world, if your phone is hacked, you are hacked. Your device is your digital soul. But Sopranus uses a multi-layered defense to decouple identity from hardware.
So what's the first layer?
Layer 1 requires real-time physical and biometric authentication, including deepfake detection.
Okay.
It checks for liveness to ensure it's actually you right now, not recorded or synthetic voice.
Okay, but what if a state-sponsored hacker bypasses the biometrics remotely?
Right, like what if they feed a perfect deepfake directly into the operating system?
Yeah, exactly. Then what?
That is where Layer 2 kicks in, which verifies the semantic codons.
The mathematical rules from earlier.
Exactly. Even if a hacker fully compromises your iOS or Android device, the attacker gets zero utility.
Because the identity isn't on the phone.
Right, because your identity is cryptographically anchored in the LifeStack mathematical fabric, not the local phone hardware.
So if the hacker tries to execute a command, like transferring money or changing your medical records,
Sopranus checks the codons. It sees the command, lacks your unique quantum-safe cryptographic signature, and violates your explicit consent boundaries.
and it just stops it.
The action is blocked at the semantic level.
So the hacker has broken into the house, but they are holding a mathematically locked box they can't force open because they don't have the quantum key.
Precisely. And if we connect this to the bigger picture, this is why the big tech labs, the massive search and social media monopolies, fundamentally cannot build this system.
Because it breaks their business model.
Exactly. Their entire multi-trillion-dollar business model relies on the assumption of access. They need to harvest your data to train their massive models and sell engagement.
LifeStack totally flips that power dynamic.
It really does.
It introduces an opt-in, opt-out consent engine. You actually have the power to say, share nothing, or share some data for personalization.
Or even share my data, but you have to financially compensate me for it.
Right. It turns you from a product to be harvested into a sovereign digital entity.
It replaces compliance theater. Those endless 50-page terms and conditions no one ever reads with cryptographic mathematical consent.
Software rules and bone-conducting voice assistants are great for protecting my search history.
Sure.
But as we established at the beginning of this deep dive, AI is moving into the physical world.
It is.
What happens when a superintelligent AI goes rogue on a civilizational scale? A voice assistant isn't going to stop a swarm of autonomous drones or a compromised autonomous power grid.
No, it definitely won't.
Software can always be ignored if the physical computer is compromised.
That is the nightmare scenario. And it's why the final piece of this document stack outlines the ultimate backstop.
Which is the SES framework.
Right. That stands for Silicon-Embedded Sovereign AI Architecture.
Yeah.
It is quite literally a civilizational architecture for safe superintelligence.
Meaning we aren't just relying on software to police software anymore. We're baking the safety rules into the actual physical silicon chips.
Exactly. The core primitive here is the deterministic ethical gate, or the DEG. This is where the post-quantum math meets the physical world.
But how does a piece of silicon, like a dumb piece of metal and sand, understand complex human ethics?
It doesn't.
It doesn't.
No, and that is the brilliance of the design.
Yeah.
The hardware doesn't try to understand the nuance of the AI's policy.
So what does it do?
The deterministic ethical gate acts like a physical padlock or a bouncer at a highly secure club. It doesn't run an operating system that can be hacked.
Okay.
When the AI wants to execute a high-risk physical action, say moving a robotic arm in a surgery room or rerouting a city's power grid, it must present a cryptographic receipt generated by the LifeStack layer.
So the AI essentially says, I have checked my rulebook, I have verified the human's consent, here is my mathematical proof.
Right. And the deterministic ethical gate simply checks the math on that receipt.
Is the quantum signature valid? Is the watermark present? Has the consent been spent?
Exactly. If the receipt is invalid, missing, or forged, the hardware physically blocks the electricity from flowing to the robotic arm.
It just cuts the power.
It is a non-negotiable state machine. It fails closed.
Here's where it gets really interesting.
Yeah.
The documents describe what happens if an anomaly actually manages to propagate through the entire network.
Right. The worst case scenario.
Say a massive supercluster of AI goes completely rogue and starts exhibiting that trajectory level failure we talked about earlier.
Then the CSAA framework has an automatic hardware level fallback called the Safe Civilizational State, or SCS.
Yes, the entire grid immediately degrades to what they call a minimum viable civilization.
Which is exactly what it sounds like.
Then think about when your computer crashes and it reboots in safe mode.
Oh yeah, that's a perfect comparison.
It kills all the fancy graphics, it stops all the third-party apps from running, and it only loads the absolute bare minimum drivers needed to keep the machine breathing so you can fix it.
Minimum Viable Civilization, or MVC, is exactly that, but for human society.
It shuts down all discretionary AI.
Right. No more AI financial trading, no more AI content generation,
Oh, wow.
no more AI optimizing your morning commute.
It drops into an island mode that only allows hard-coded lifeline services to run.
It preserves healthcare triage, the stability of the water and power grids, emergency communications, and life-saving logistics.
And that's it?
That is it. It is a literal, hardware-enforced kill switch designed specifically to preserve human survival while the system is cryptographically audited and rebooted.
It's treating AI alignment not as a polite request, but as a hard dependency of compute.
I love that phrasing. Yes.
If you don't have the math proving you are aligned, the silicon simply refuses to process your electrons.
It forces compliance to be the cheapest, most dominant strategy for the machine.
So what does this all mean? We've covered an incredible amount of ground today.
We really have.
We started with the hidden dangers of AI drifting off course and executing unsafe trajectories. We went down into the post-quantum math of codons and the golden ratio preventing that drift.
Which was heavy, but necessary.
Very necessary. And then we explored the real-world protection of the Sopranus voice assistant standing between you and the surveillance economy. And we went all the way to a silicon kill switch designed to preserve civilization itself.
It is a massive, comprehensive vision for how we survive our own creations.
But what does this mean for you right now as these technologies are being actively built?
That's the real question.
The core takeaway from Richard Lyon's research is this. In the age of autonomous AI, your data is your destiny.
Absolutely.
Without cryptographic mathematical consent, your digital twin, the version of you that lives in the algorithms predicting what you'll buy, who you'll vote for, and how you feel can be manipulated, harvested, and steered.
You need a system that fundamentally remembers who it serves.
And this raises an important question, and perhaps the most terrifying limitation mentioned in the entire stack of research.
Yeah, this is the part that keeps me up at night. It's the problem of honest initialization.
Meaning who actually turns the system on and sets the rules on day one.
Exactly. The entire LifeStack system relies on the initial codons being set by an authorized, honest entity. It assumes the starting conditions are good.
But if this cryptographic identity is truly permanent,
Right. If it is anchored in post-quantum math that cannot be cloned, cannot be hacked, and cannot be overwritten.
what happens if the very first entity to initialize a superintelligent AI encodes slightly biased or flawed or self-serving human assumptions into that unbreakable math?
That is a chilling thought. Once that cryptographic lock clicks, it might be mathematically impossible to change who that AI fundamentally is.
We are talking about locking in human values with all our current flaws and blind spots forever.
Are we wise enough right now as a society to write the permanent, unchangeable DNA of a new digital species?
Because once the golden ratio is set and the physical silicon gates are locked, we have to live with the entity we've created.
We will have built a cage so strong that even we cannot open it to fix a mistake.
It brings us right back to that GPS analogy.
It really does.
We might be building the most secure, mathematically perfect, unhackable navigation system in the history of the world.
But we better be absolutely certain about the destination we type in before we hit drive.
Thank you for joining us on this deep dive. Keep questioning the invisible systems around you, and we'll see you next time.